Okay, as you already know that the creational design patterns is one of the classification under detailed design patterns. Okay, so what is the creational design patterns? So it is the creational design patterns provide the abstraction and control, the way we create the object. And the abstractions is what are the components that should be inside these design patterns, and then control how they create the object. So they use a common creational interface. So this common creational interface can be used to enforce the creational policies. So when we want to create the new concrete object, we can use this creational interface classes. So that the object that we create, the concrete object that we create, has a uniform policies, the same policies. So for the creational patterns, we have a large number of creational patterns actually, but for this course we are going to cover only the abstract factory methods, builder, prototype, and singleton. So next we are going to focus first on the abstract factory. So the abstract factory is an object creational design pattern that to manage and consider the creation of a set of objects, or we call it as a family of products. So we control the creation of product families, so that have a common characteristic based on the interface classes. So there are two main element or component in the abstract factory pattern. First is the creator classes, and the second is the product classes. So the creator and product have their own interface classes, and then it is used to create the concrete object as a uniform object. All right, to understand the abstract factory design patterns, so we have to consider or study first the structure of the abstract factory design patterns. So as mentioned earlier, there are two types of classes. We have a creator classes here, and then we have the product classes. So the product classes and creator classes is the main part of this abstract factory design patterns. So the abstract factory and abstract product have a interface. So this is a interface class for this product, and then is a concrete factory where it's create the product A, create the product B for the family of products. So this is, we call this the product family. So family of products. If we want to add the additional product, we add a letter. So the main point here is to understand on the client object. When we want to add the new product, so we don't have to change the code of the client object, because the new product share the same interface. For example, the abstract factory have a create product A and create product B. The concrete factory one also has a create product A, product B, product B, even though the implementation is different because they create different product. This one A1 and B1, this one A2 and B2. Okay, but the client only give a same comment, so we don't have to change the code in the client class whenever we add the additional concrete class. So that is, if you still remember, this comply with the open close principle. Okay, so the next slide show you how when we want to add the new family of products. So when we want to add the new family of products, we just add the new concrete factory 3. Okay, so we have a concrete product A, concrete product B, but it will create the concrete product A3 and B3. So at this point of time, we don't have to change anything here. So the client will remain intact. So it will improve the maintainability of the program, or modifiability of the program. Okay, if we want to add the new product, here we need to add the new interface. So new interface, abstract product C, for example. So for this family, for the first row family, it's also add the product C1, C2, and C3. And then we have to make some modification here. The create product C. Okay? So even though we have to add also the create product C in the abstract. So at this point of lecture, I hope that you understand the structure of the abstract factory design pattern before we move to the example. Okay, now we are going to discuss an example for the abstract factory pattern. We use a simple and fictional example to make it easy for you to understand how the abstract factory works. So in this example, we will consider advanced computer and standard computer as a two different product family. So this is a two different product family. And then the products for each product family consists of CPU, keyboard, and monitor. So for advanced computer, they have their own keyboard, CPU, and monitor. And then for the standard computer, also have a CPU, keyboard, and monitor. For example, they have a single core CPU for the standard, and then the latest multi-core CPU for the advanced. So they have a different behavior, even though they have the same interface. Okay. So this is the illustration of the main program for this example. So in the main program, the user can select advanced computer or standard computer, or select to exit. When they select advanced computer, the concrete object will find its associated sources. So each computer product is associated with one or more information sources. So it's different sources. So it will be different implementation. Here is the class diagram for our computer store example. So if you see the diagram, you will notice that it follows the components described in the structure of the abstract factory design patterns, where you have a creator classes here, and then where you have a creator classes here, and then you have a product classes here. So you have both creator and product classes. So for the creator interface, we have a computer part factory interface, and then for the product interfaces, we have a CPU interface class, monitor interface class, and keyboard interface class. And then we have also two product family here, two product families. The first product family is for advanced computer, and then the second product family is for standard computer. Here is the implementation for the product interface. So the first interface is CPU interface. We have also monitor interface and keyboard interface. So this is C++ construct. If you want to use the C# programming language, the code is slightly different. So we have here, if you see here, the semicolon n equal to 0, that means there is an interface method for the interface class of CPU. Yeah? And then we also have a monitor and then the keyboard. So the CPU product design, this is a concrete class for the CPU that implements. Yeah? So implements in C++ is like this. So this is the .head.h file. So it will declare the class, this concrete class, in the .h file. So if you see here, it's a semicolon because it is a header file or interface file for C++. For the this is for monitor and then for the keyboard. And then for the implementation .cpp class, you can see for advanced CPU and standard CPU for the product class. So this is the implementation. Where you got it's another implementation. So the implementation, if you notice here, implementation of advanced CPU, even though the name of the method is same, but the implementation is different because this one display the advanced and this one display the standard. You take from different database for standard and database for advanced. So for the concrete implementation, it's different, but use the same method name, and then it's implement the same interface. It's implement the same interface. So standard CPU and advanced CPU and standard CPU implements the same interface. If you see here, CPU is the interface implemented by the advanced CPU and standard CPU. So they have the same method. They display CPU information, but different implementation. This one is a header class. Implementation we can see here. So it's different implementation. Compare here and here. Okay. Just like example in the OCP, open close principle example in the previous lecture. Okay. So now for the other products implementation, like a keyboard, keyboard for the advanced keyboard for the standard computer, standard keyboard, and advanced monitor, standard monitor. So it will follow that. They have a different implementation. They have a different implementation. The keyboard. So that's one we're done with the products part. Now we are going to continue with the creator class. We have a standard computer creator and then advanced computer creator that derive from or implements the interface of the computer parts factory that have the creator method. Okay, so for the creators, here we have advanced computer parts in this example. So we have the advanced computer create monitor will create the object of the advanced monitor. Create CPU will create the object of advanced CPU, and then create keyboard will create the object from the create keyboard. So it will return the object of the new advanced the advanced monitor, advanced keyboard. This is the product family for the advanced computer. And then this one is for the standard computer. So we have a standard monitor, standard CPU, and a standard keyboard. The same thing. It will create the monitor, create the keyboard, and then create the CPU. It will return the standard CPU, return the standard monitor, and return the standard monitor. Okay, so it means that even though the name create monitor is same across the interface, but the object that's written is different. Okay, now that we have seen the implementation of the creator class and the product classes, so now we are going to see how to implement this computer class as a client for this abstract factory design patterns. In our example, it's a computer store. Okay, so for the client computer design, so here we have a .h file. Here we implement this computer class in the .h file. So we have a constructor. So the constructor we receive is the most important part that you have to understand. The constructor will receive the reference to the object, computer parts factory, computer parts factory. Yeah, and then it also have the private or the attributes of monitor, CPU, and keyboard. It is also the pointer to the object. So when it is passed as a pointer to the object here, so it will display monitor, display CPU, and display keyboard. So the implementation is not here because it is a .h file. So the implementation is in .cpp file here. So if you see here, display monitor, we'll take a monitor object as a reference, dash display monitor information. Okay. So keyboard, display keyboard information, and the CPU will display the CPU information. Because during where this object come from, it's come from here. Okay, so you have the what we call the parameter is passed by reference. So we don't know at the compile time whether it is a advanced computer or a standard computer. If it is advanced computer, the advanced computer object will pass here. If it is standard computer, the standard computer object will pass here. But during design time, the class computer don't know what type of object that it will receive. It only knows what kind of object it receive during runtime. So this object, we go here, and then the computer part factory, if the standard, if it is advanced, it will create monitor, create keyboard, and create CPU assigned to this object. And then when this method is called, so it will call the respective code. So the implementation depends on the concrete class. So the interface is same. So we don't have to change this part of codes in the client computer. So we maintain the same code even though we change the concrete product here, whatever concrete product here, and then what we pass here is different. Okay, so this is the putting all together. This is the main program. That's give the option, and then it will pass the parameter here. If the user choose 1, it will pass the advanced computer, choose 2, and then it will pass the standard computer, and then it will print computer display, monitor info, display keyboard info, display from the computer client. So the computer client doesn't need to know what kind of object is passed during runtime. So during design time, it's already because it specified. So this one, if you still remember OCP, open close principle, it comply with the open close principle. So this is a step-by-step summary. This is very the thing that we already done for the implementation of Abstract Factory. We design the product interface, CPU monitor, and then identify the different family groups, and then design the concrete product, and then create the factory interface. This one is the creator, and then for each family of group identifiers in step 2, create concrete factories that realize the factory interface. Associate each factory from step 5 with the respective product. So we construct the product family here, and then create the client that uses our patterns. Okay, so the consequences of Abstract Factory, the advantages of having this is many. So isolates concrete product classes that using becomes easy to reuse. Promote consistency among product families, and then adding new family product require no modification to existing codes, and then help minimize the degree of complexity. So it's easy to understand, especially during the modification of the program or the maintenance. So the only disadvantages is because a large number of classes required. So for each product family and each product, so you have to create the class. So it seems like the last number of files here, but it may give the benefit that's already started design patterns. So with that is end the first part of the first session of this lecture.